Morning everybody, welcome to the OCS I planning the installation webinar. Let's get started.
Hello and welcome to today's webinar. Today we're going to be looking at planning an OCS I installation. Let's get started. Let's look at our agenda for today. Firstly, we'll have a quick review of OCS I. Then we're going to talk about what components you need for the installation. We'll talk about connecting OCS I to your OCS all-in-one controller, and of course we'll also look at connecting up sensors and actuators to the I/O terminals on the product line. There will be demonstrations throughout, and we'll finish with a Q&A session. OCS I is our newest group of expansion and remote I/O, which has been designed to complement any Horner automation control system, for example the micro OCS, which is a small I/O count, to the XL Prime, which can have a large I/O count, and anything in between. And this is not a brand labelled product, it's a ground-up design using off-the-shelf mechanical components from Phoenix Contact. But all electronics, all the circuit boards, all the firmware, everything else is all Horner. This is an I/O system that is fully integrated into our OCS all-in-one controllers and into our Seascape application programming environment. It's designed to work well with any OCS regardless of which series you're using. The base that is part of OCS I/O includes a mix of I/O that can complement a small system. In some cases, that may be the only extra I/O you need, but this product has high capacity, which makes it an excellent choice for larger control systems, and you can have up to 8 modules per base, and then you can have up to 8 fully loaded bases. So it's a very scalable product. And while we're not planning on obsoleting any of the other products, OCS I/O will quickly become the main I/O offering. Next, we'll look at the components you need to try this I/O system in your next application. We'll start with the CNX I/O base, regardless of the size of the system, and this base provides the network connection to the OCS controller that's running the system over the C-SCAN network. So even though there are RJ45 style connectors on the front of the CNX base, it still uses CAN, but we've utilised Ethernet style patch cables as an available way of connecting devices between the OCS and the OCS I/O to make wiring easier. There are a few I/O points that are built into the base, a mixture of digital and analog, and in some cases may be the only I/O you need to add to your system. So we start with the CNX base, and for the next few months, when you order a CNX base, you'll have the ability to order what we call a backplane connector assembly, either a 4-position or an 8-position, and the part numbers are there on the screen. And you'll receive that assembly with those backplane connectors pre-assembled at the factory, so when you receive your base and you receive the backplane connectors already assembled, you'll be ready to get started with your system straight away. And once again, when you order your CNX base, you have the ability to specify one additional part number, the HE-CON4 for a 4-position backplane connector assembly, or the CON8, which is an 8th position. And we'll look at that in a minute. If you're using more than just the I/O that's built into the base, you're going to need additional modules. And we have 6 different modules that are available to use as expansion with the base. So you can have a total of up to 8 modules per base, counting the base as a module. And it doesn't matter what combination you choose for your application, it can handle any combination of other modules. You're also going to need end clamps for the DIN rail. OCS I/O snaps onto the DIN rail, but to keep it squeezed together with each module to the base, you need end clamps, one on the left and one on the right. On the right, it's just a normal end clamp, whichever style you prefer or have already been using. But on the left, we need to use a special end clamp because the backplane connector protrudes slightly from the base on the left-hand side. So the Phoenix Contact makes a special end clamp, and the part numbers are there on the screen, and that does the job of clamping the OCS I/O and not interfering with the backplane connector. But again, that's only required on the left-hand side. Now we'll look at putting all of that together. So here's our OCS I/O base, the CNX, and you can see that we have our RJ45 connectors for C-SCAN, and we can connect the power and the built-in I/O there as well. And then when you order this product, this is where you can specify whether you want a 4-position or an 8-position backplane connector, pre-assembled and ready to install on the DIN rail. This is something that will happen for a few months until Phoenix corrects the difficulty in getting these units plugged in together, or makes it a little easier to do in the field. So that's what it looks like to order a 4-position backplane assembly, for instance. So to assemble it, the first step is to get your backplane assembly mounted on the DIN rail and plug in your CNX base. Then you'll want to line it up close to the next connector, use the top of the rail as a pivot point and just snap down. So it's really not difficult, especially once the first one gets in, it gets easier from there. If you look closely on the left hand side, you'll see slightly protruding on the left is that backplane connector. So that's why you need a special end clamp on this side and you don't need it on the other side. So that's what it looks like to receive your backplane assembly and to insert it onto the DIN rail to quickly assemble your OCS I/O. Next we'll look at connecting your OCS to the OCS I/O. The OCS I/O will be compatible with the micro OCS, the XL series, the XL Prime, but it will require a firmware update. In order for that compatibility to exist, we're doing it in slightly different order. So the XL series will be the first to receive a compatibility with OCS I/O. And then we're going to be adding XL Prime, and then we'll add micro OCS. So all of those product families get firmware updates to support OCS I/O, and Seascape already supports OCS I/O. Now look at the details of the wiring. For a micro OCS, the CAN port is based on RJ45 connector. So to connect the micro OCS to the OCS I/O, you just use a standard unshielded Ethernet style patch cable. One important note is that even though we're using RJ45 type cabling, we still need termination on both ends. But on the OCS I/O side, there's an accessory that is highly recommended, called an RJ-TRM121, which is a plug that you simply plug into the open port of the OCS I/O when it's last on the line, and it provides termination. If you have an OCS with an open style CAN connector, XL series or XL Prime series, there's only 3 signals that are required when you come up with a cable to connect an open style C-SCAN connector with OCS I/O. And that is CAN high, CAN low, and ground, or V- as it's sometimes called. And we recommend that as pins 1, 2, and 3. Now you have the option to buy a cable from Horner. There's a 3-footer and a 6-footer, and at one end has an open style connector ready to plug into your OCS already terminated, and the other side has an RJ45 type connector which you can plug into the OCS I/O, so that's available as a control accessory. You also have the option of building your own cable. You could start with just a plain category cabling, or you could even take a pre-existing patch cable and chop off one end. Again, there are only 3 conductors to worry about: CAN high, CAN low, and ground, or V-, and we can see on the screen there the pinout. So we're going to use the orange-white, the orange, and the green-white conductors that are part of the category style cable. Now we look at termination in a bit more detail. Termination occurs on the 2 physical ends of the network, so it doesn't matter what the device is, if it's on one of the ends then it needs to be terminated. Now for OCS I/O we have the RJ-TRM121 accessory plug, which isn't very expensive and is highly recommended, so we plug that into the second port if your OCS I/O is on the end of the network. If you have an OCS with an open style connector, you're going to terminate it using the termination resistors that come in the box with the open style connectors when you purchased your OCS, and you can see what that looks like there on the screen. And then again, if you have a micro OCS, it has an RJ45 connector, but it only has one for CAN. So to terminate that, we go to the system menu, and in network settings for the system menu, you can enable termination on the CAN network, so it's not a complicated process. If you need to connect multiple bases, you can simply daisy chain those bases together using standard patch cables and whatever devices happen to be on the physical ends of the network that requires termination. If it's an OCS I/O block, you can use the terminator plug. If it's an open style connector, you use the resistor, and if it's a micro OCS, you use the system menu. If you're doing all your wiring within a cabinet or you have 50 feet or less, category wiring is robust enough. If you have longer distances and you are wiring outside a cabinet, you can easily convert back and forth between category wiring and CAN wiring at the field terminal strip. So, if you have a long network, you might use thick cable, which is good up to 500 meters. If you have a network of 100 meters or less, you can use thin cable, and if it's somewhere in between, you can use mid cable, that's good for up to 300 meters. But inside each cabinet on the field terminal strip, that's where you can convert back and forth between CAN wiring and category wiring, and we can see the pin there on the screen. Now we'll look at using sensors and actuators, and more specifically connecting them to the OCS I/O. Now, all OCS I/O field connections are made to removable spring clamp terminal blocks. All positions are labelled, unlike the picture on the screen, and we have 2 styles of terminals. We have a 6-pin and a 4-pin, so every module will use one of those 2. You don't need any tools for inserting wiring if you use barrels, and you'll need a small screwdriver for removing individual conductors and a medium-sized screwdriver for ejecting terminals and removing I/O modules for the DIN rail. Now we'll look at the wire gauge. There's no need to use excessively sized wire. For almost all applications, stranded 18 gauge has plenty of ampacity, much more than 10 amps, and it's easy to work with. Also, if you use ferrules, we recommend that you use ones with 10mm barrels on them to make insertion and removal easy and to make sure you get a good connection on your ferrule as it's grabbed by the terminal. If you're using standard analog signals, 4 to 20 milliamps, 0 to 10 volts, etc., use shielded twisted pair, and an example of that would be Belden 8441. If you're using thermocouples, you need to use thermocouple extension wire between your sensor and the OCS I/O so there won't be any junctions that cause error. If you're using RTD sensors or 3 conductors, shielded cable is appropriate, for example Belden 9533. Also, with any of the analog I/O or thermocouples RTDs, if you're using shielded cabling, it's important to earth ground the shield at a good ground, and if you have a good ground of the sensor, that's often the best place. However, if you're going to ground it inside the control enclosure, do it at the ground point for the control enclosure inside the cabinet but not on the OCS I/O terminals. There are no OCS I/O terminals for earth ground for landing shields, and that's on purpose because it's not the best place to drain any noise that you may have in your system. Now we'll look at how we might add wires and do a variety of other things in our application. Firstly, we'll show you how to effectively pull a module out of the middle of the system. In this case, we use the medium screwdriver, and so you put your medium screwdriver through that orange slot and you're going to pry up slightly on this tab that is keeping the OCS I/O attached to the DIN rail. So we'll do that down here, and you can see that we very easily take this module out of the middle. It doesn't have to be on the outside. And then we can very easily either put a replacement or the same module back in. So now we'll see how to eject terminals. These are all removable terminal blocks, and to get them out, we'll put the same medium-sized screwdriver through the same orange slot, but this time we pull down and the orange tab is going to eject all the terminals. And then when we want to push them down, we push them down. So that's how to eject terminal blocks. Now we'll look at individual conductors and what we might be using in our system. So this is what we recommend for most of the wiring, except for the analog, on OCS I/O. So this is 18 gauge and we have it terminated with ferrules. And this is a ferrule that has a slightly longer barrel, it's 10mm long. So for digital input and output wiring, we can just push in like that. If we need to take the conductor out at any point, we just push down on this orange lever and the wire comes out. Now you'll also notice there's a really small probe hole here, so if you have a small probe and you want to do some testing without having to remove any wires, you can do that. So this is 18 gauge wire with a 10mm long barrel on the ferrule, which is what we recommend for digital I/O inputs and outputs. And you can go smaller than that if you want. Now we'll take a look at a typical wire size you might find for your analog wiring. So this is a 22 gauge wire that you might find as part of any of those recommended wire or cable types that we talked about before. Again, it has a slightly longer barrel on the ferrule and it goes right in and comes right out. This is a 22 gauge wire and you can go down as far as a 24. Now the last thing we'll look at is why we're not recommending the shorter barrels on your wiring here. And that's because if we push it into the hole, it goes in fine, but it doesn't stay. And that's not what we want. So that's why we're not recommending 8mm barrels on your ferrules for your wiring. So that is a look at how to take a module out and how to eject your terminal blocks and the types of wires and ferrules that we recommend for your system. So to install OCS I/O, you'll need to order a CNX I/O base regardless of how much or how little I/O you're going to add to your system. If you're going to add any modules at all, at the time you order your I/O base, at least for the next few months, you're going to need to order, at no extra cost, either a 4-position or an 8-position backplane connector assembly. And then, if you're using more than just the base, you need to order whatever expansion modules that you choose. You'll need end stops to keep everything tight on the DIN rail. The left-hand end stop needs to be slightly different so it doesn't interfere with the backplane connector. The end stop on the right can be whatever you normally would use. For cabling to connect to your OCS, if it's just micro OCS, everything can be patch cables, where all you do is plug and play. If you have an open style connector on an XL series or an XL Prime OCS, then you're going to need an RJ45 to open style cable that you can either make yourself or buy from Horner. And then when you terminate, if you have an OCS I/O block or I/O rack at the end of the network, it will need an OCS I/O terminal plug. And then you'll need 2 different size screwdrivers, one for injecting conductors, the other for ejecting modules and terminal blocks. So that concludes today's webinar. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, folks, so hopefully that was all clear and makes obvious how we put together the I/O rack for the OCS I/O. an improvement over SmartRail, I'm sure you'll agree. I don't see any specific questions coming in, so let's skip on to the upcoming webinars that we've got from Morna. So let's try and get those on screen. Okay, there we go. So first one there is the one we've just seen, planning an OCS I/O installation. And then the next 3 weeks are all to do with OCS I/O as well. So we look at the universal analog input module, we look at the digital I/O modules, and we look at configuring the OCS I/O in Seascape. So next 3 weeks we've OCS I/O again as the subject for the webinar, and then we're on to a data find UDFBs in Seascape. For those of you using UDFBs in the variable-based advanced ladder, that should give some good pointers to using the UDFBs. So they're the upcoming webinars. Thank you very much for your attendance today, and we'll see you all next week. Thank you very much.